Hi friends, this is Sarujan here. Welcome to my networking channel. Hope all are doing good and safe. And today let us discuss about EIGRP stub routing. So EIGRP stub routing used in a hub and a spoke topology in which configuring we can configure the remote or the spoke router we can configure as a stub router. So that means it will reduce the query range. So R1 will not extend the query further to R2 if I am configuring the remote router as a stub router. So that is the main advantage of stub routing. And also in case of stub routing, it will reduce also the size of the routing table. So by default, stub contain only the connected and the summary routes. So to always advertise the connected and the summary route to R1. So in that case, we can reduce the size of the routing table, and also R1 will not extend the query further to R2 if I'm configuring this as a stub routing. So I'm going to show how to configure the stub routing. So always the stub routers are not queried, but hub routers. This router will answer the query on behalf of the stub router. So another advantage is hub router. If in case of multiple hub and spoke topology, the hub router will not use stub router as a transit path to reach another hub router, right? So these routes are not reflected back to again hub router. So that is the main benefit of configuring the remote router as a stub router. So now let us go ahead and configure the EIGRP routing, and I will show how the stub routing reduce the query range. So now let us go to R1 and let us configure the EIGRP routing protocol, right? So before that, let us view the directly connected interface. Show IP interface brief. I configure the 192.168.1.1 and 2.2. So let us define the network, right? Let us go to the configuration mode. First, let us define the network. Router EIGRP 100. Network is 192.168.1.0 and loopback is 2.2.2.0, right? So I have defined the loopback address also. So now let us go to R2 and let us configure the routing protocol. So router EIGRP 100 and the network again is 192.168.1.0, right? So I define the network. So now let us check the running configuration. So running configuration, let us view the running configuration. So I already I not done any stub routing. So without stub routing, let us see the behavior of the query range. So how EIGRP is extending the query to R2, right? So now let us check the, I will not configure R2, no stub routing, right? So now let us check the query range. What we can do, before that, let us check the neighbor relationship. Show IP EIGRP neighbor. So the neighbor is up, right? So what we can do now, let us debug the EIGRP. Before debugging, what we can do, go to the configuration mode, loopback, interface loopback 0, and let us shut down. That is loopback 0, right? So I have shut down the interface. So now let us debug the EIGRP packets query range. So I want to check the query range of R1 and R2. So debug EIGRP packets query. So let us query the EIGRP packets, right? So what we can do, let us go to configuration mode now, interface loopback 0. Let us do a no shut again, and let us shut down the interface. So you're able to see, right, immediately sending the query. It is sending the query and it is also receiving the query, because still I have not configured this as a stub routing. So R1, whenever a loopback I shut down the interface, it will immediately send a query to R2. So what happened? R2 is also receiving the query and it's again sending the query to 192.168.1.1 about the network, right? It's sending the query further to R1. So that is the case when the EIGRP stub routing is not configured. So now let us go ahead and configure the EIGRP stub routing on R2. So how to do that? Go to configuration mode and router EIGRP 100. So before that, let us no shut this interface. Configuration mode, interface loopback 0. Let us no shut. So now I'm going to configure this as a EIGRP stub routing. EIGRP stub. So this is the configuration I have done. So now let us see the query range. So what we can do. So now I'm going to shut down the loopback interface. So go to the configuration mode, interface loopback 0. Let us do a shut. So what happened? It will only receive the query, right? It is not sending the query further to R2. That is the advantage of stub routing. So when I'm configuring the remote or the spoke router as a stub routing, what happened? The queries are not extended further to R2. And R2 also, only the stub router, what happened? The stub router only will send a query, but the queries are not extended further to R2, right? So R1 will not send a query further to R2 when a single network outage, right? So that is the main benefit of configuring remote or a spoke router in as a stub router. So we're able to see, right, after configuring the stub routing, what happened? It is only receiving the query, but it will not send the query to R2. But the stub router will send a query. You are able to see, right? Stub router is only sending the query, but the stub router will not receive any query from R1. So that is the benefit of configuring the remote or the spoke router as a stub router. So it will reduce also the size of the routing table, and configuring the remote or the spoke router as a stub router also will reduce the query range. So R1 will not extend query further to R2. So also again keep it in mind, R2 as a stub router always advertise a connected and the summary by default. So let us see here, show run. So after configuring the stub routing, you can see only the connected and the summary route, right? So these are the default for stub. That means it will advertise the connected and the summary routes to R1. So in that way, we can reduce the size of also the routing table in R2. So that is the benefit of stub routing. I hope you understand this video. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.